Hi everyone. I know this video is a little bit different than what I would normally do, but it's not often that my day job as being CTO of Dymaptic gets to intersect with my night job of building random things. Recently, I had the opportunity to give a presentation about the Anywharrow at the GIS in Action conference here in Portland, Oregon. The Anywharrow is an arrow that when you press a button and speak a location, it will turn and point you to that location, much like a street sign or a trail marker sign. This video is pretty much the uncut recording of that presentation. I've added chapter markers because I think some of it's maybe kind of long and boring or wandering as I talk about things like the importance of AI and the future of user interface design. So if watching me give a presentation is not your thing, just give this a like and wait for the next video where I'll go through all of the trials and tribulations of building the Anywharrow.
Any place you can think of. What is the first thing that popped into anybody's head?
Cuba.
Cuba, all right, you got it. Cuba. And so what's happening is I press this button and it's listening to my voice, it's transcribing that into text, and it says Cuba is that way. I don't know if that's true. It did get Cuba though. It goes through an AI model and then figures out where to point. So this started, I don't know, last fall sometime. I went for a walk with some friends and I saw this in one of our neighbors' yard. And I thought, man, that would be so cool if I could build a voice-activated version of that. And so now this thing exists because I couldn't resist, basically. I'm really into this idea of alternative UI and building UI things that are not what people expect and kind of behave in a different way. I want to take a quick stop and talk about AI. I'm not going to talk about this a lot. I'm actually doing a whole presentation on this in the fall at another conference, but AI it's controversial, it's powerful, it's weird, it's different, it's uncomfortable, but it's also kind of amazing. So I'm into this idea of using AI to build alternative UIs that are not chatbots. Okay? I think chatbots are frustrating sometimes because they're not quite human level, but gosh, they're close and uncanny sometimes. But what we can do is we can build other types of UIs. We can build other types of interfaces. So one of my favorites is protecting user input. So basically, if a user can type in information into a box, we're going to save that, and then we're going to put that information on a public web page. Like if you're naming an adopt a drain or something like that. Well, sometimes humanity they do really gross things when they name things in public. Okay, I don't know. It's terrible sometimes. Nobody wants to read all of those and decide whether or not they're allowed or not allowed. So you put AI in front of that and let it scan most of those. And you can give it a relatively simple prompt, like, don't say anything you wouldn't say to your mother. And 90% of your problems go away, and you're left with a very small bucket of things. So it's this idea of using AI to replace us in jobs that we typically think of as only a human can do, but it's actually really good at. It's really good at doing that. It's really good at fuzzy matching. For March Madness, we had a company pool. And of course, I am not a basketball person, so what I did is I trained a model to do my March Madness picks. And the first problem I had is I had a huge volume of data, and none of the team names matched up. I had Nebraska, Nebraska State, Nebraska ST, Nebraska ST period, Nebraska Huskers, or whatever they're called. I don't know any of these. I don't have this information in my brain. Plus, there are hundreds of them. I cannot do this manually. So traditionally, I would write, I don't know, a pile of regular expressions or something like that to get through it all. I could still do that. Or what I did in this case is I asked AI to standardize the names. And I gave it some rules. I told it kind of what I wanted, gave it a handful of examples, and then passed every data set through it, standardizing the names so I could do my joins like I normally would in my data science tool. Worked great. Did it make some mistakes? Probably. But for March Madness, I didn't care that much. But in a real project, I would want to do some QC on that. We use it for fuzzy matching for our clients from time to time, and it does really well. It actually is probably about a 90% accuracy rate, which is about as good as a human. sometimes better than a human because we get tired and don't pay attention and things like that. It doesn't get tired. So anyway, that's all I'm going to say about AI, really. Now let's talk about this sign. So, like any good project, you must always start with what are you going to build? So what I wanted was a sign. I wanted it to be able to point in arbitrary directions. I wanted it to be voice controlled, but not voice activated. I've done other projects that are constantly listening, and I kind of wanted to do an experiment with having a button interaction. So in this case, it doesn't listen until I press the button. What else did I want it to do? Oh yeah, steampunk. That was a later add-on, but I wanted it to have something like kind of appealing. I didn't want it to just be a jet black thing. So steampunk is my chosen aesthetic in this case, and I think it actually, I think it turned out really great. I'm really proud of myself for that, because I do not count myself as an artist. So to me, that is amazing. It needed to be able to survive this, and making it here for a presentation, and having people give it random pieces, random locations that it might have to spin and figure out. And my ultimate goal is that it goes on the porch. One of our porches is right on the sidewalk, and I want to set it up there with the button and some instructions, and I want people to kind of be able to experience it, and I want to see what people do and what they ask it to do, and see how they interact with it. So that was what I was trying to build here. Okay, so how many of you are hardware people? Have you ever used a Raspberry Pi, an Arduino, something like that? Okay, great. How many of you have written a Python script? Awesome. All of you are one step from being a hardware person, because you can run Python on microcontrollers now, and not just on Raspberry Pis, on really low-powered things. So you can make, I have a coworker that did this. He made himself a light that turns on when ArcGIS Monitor has an error. Okay? And he did it in Python, all in Python on his little microcontroller. So I keep trying to talk him into doing that talk, but anyway. So you're almost there. Okay, so this is what it looks like. We've got a big old Raspberry Pi in the middle that kind of controls everything. We've got a screen that's over here. You can see kind of the front and the back of it in the photos. It flips around, although I will, spoiler, at one point I did consider buying a second screen because making it flip was hard. So 2 motors, one to spin it, and one to rotate the screen. Magnetometer, gyroscope, and accelerometer, so it gives 9 degrees of freedom that you kind of blend together to get a heading, so that I have a nice clean heading as it spins around. That's also really tough. When we play with it in a little bit, you'll see that it struggles sometimes because in here the magnetic fields are all wonky, and even my phone in here is actually struggling, which is weird. That this particular room is bad. So then we've got that motor board sitting in there. You can come up and look at it later, but there's 3 boards stacked in here. The nice thing about modern electronics is people just make these things to stick together. Like when I was in college, I have a degree in electrical engineering, and then I went into GIS. Right? We've all heard those stories, right? It was so hard to do things like this. They're like manually hooking hundreds of connections together, and now you just buy them on Amazon and stick them together. It's kind of fun. I get to the fast part, the fun part fast. And then an audio board, right? So it has a microphone so that we can see what's going on. Okay, so all of those things, some CAD, to build this. The whole thing is 3D printed, minus a few off-the-shelf metal parts to give it some more structure. And then we take all of that and we get some software. Okay, so in the background, this has a bunch of things that have to happen all at the same time. So this is all done with async IO in Python so that you can have parallel processes running together. I highly recommend, if you've written any reasonably complex Python script, I highly recommend looking into async IO, because once you kind of get the hang of it, you can do a lot of it. It's just easier to program, well, I want this to happen, and I want this to happen, and I want it to happen at the same time. It just kind of makes it a little easier. So we need to read the current heading from our little magnetic sensor on there. We need to rotate the sign on command, so after a voice command finishes, it needs to be able to spin the sign. Listen for that button press so that it can record the audio. It also needs to be able to update it. if you want to come look at it later, I'll show you it actually is streaming live information off of the sensor, so you can spin the pointer around and you can actually see what it thinks the compass heading is, and that shows up on the screen. And we need a simple web server because the easiest way to make a UI these days is in the internet. So it's actually a web page that is running in Chrome on that Raspberry Pi, and that's what makes it display. And we'll look at some of the weird complexities of that when we play with it here. Okay, what happens when I push that button? This is really the fun part and kind of the nuts and bolts of it. You push that button, it immediately starts recording for 5 seconds. So you get 5 seconds while that button is glowing blue to describe what you want. Okay? And you can really describe almost anything, and you'll see why in a second. We take that WAV file, and this is the one that takes the longest. If the Wi-Fi is slow, this is where the slow is. It uploads that WAV file to OpenAI, where it transcribes it, turns it into text. So now I have a transcription of what you just said. We take that and we put it into a GPT-4 prompt. And this is the API, it's not ChatGPT, so this is not going into their data pool for processing. This is a private API call. This is the prompt that I'm giving it. Okay, so a note about building these prompts, if you treat the thing like a human, it tends to work better because it was trained on human writing. So when I build these prompts, I do things like this. You are a special street sign called OmniPointer. When a person presses the button, there's an audio recording. I just described to it what it physically is in space. It's actually a little bit longer than this. But the goal of it is to take whatever you said, that transcription, and turn it into a location. Okay? So now we are limited to its knowledge and its knowledge of current events. So yesterday, someone asked it for a country where there's a war going on. The best it could muster was Syria. Okay, well, it's probably not really wrong, but it's maybe not the one on top of everybody's mind right now, right? So it kind of lacks current events in that sense. But it's quite difficult to stump, so I invite all of you to be thinking about weird descriptions of things. So think out of the box. An upside-down parabola, that would be the St. Louis Arch. A giant green lady. A museum with a clear rectangle or a clear triangular pyramid, the Louvre, right? So think outside the box. It'll be interesting to see if we can stump it. Okay, so we do that. We pass that to a geocoder to get a location on the Earth, and then we compute, and hopefully you all appreciate this, the great circle bearing. Not the bearing on a flat map, but the actual great circle bearing. So the direction you would walk if you actually had to walk to this location. It's really funny because showing it to people that don't think that way, they see it like they'll do Japan, and it points kind of northwest in that sense, right? And that is the arc that you would travel on, but it's not, when you look at a flat map, it's not where Japan is, right? So it's kind of fun seeing people's reaction to that. I mean, when I put it on the porch, I might have to take that out because it might be too weird, right? I might have to make that sacrifice. So once we do that, these motors are called stepper motors, and what that means is they have a magnetic coil, and it turns one click at a time. So I can move it just a few degrees at a time. I don't have to just turn it on and let it spin. I can move it just a little bit. And so basically, I figure out how many steps it'll take to spin the sign around to the place that I want. Because while the motor's on, it's creating this gigantic magnetic field that totally messes up the magnetic sensor. Right? It has no idea which way north is while the motor is on. So while the motor's on, we can't take a reading. So we have to basically turn the motor on, spin to where we think it is, and because it's like a trail sign, it doesn't have to be perfect, right? We're not looking for decimal accuracy here. We're just like plus or minus 10 degrees, and I'm happy with it, right? Okay, so that's basically, oh, I forgot to say, then the last thing it has to do is figure out which way around the screen should go. So I'll show you that. If you can think of something that is that direction. So you may have that.
Mount St. Helens?
Mount St. Helens, that works. That sounds like that direction. Mount St. Helens. I always get nervous whenever I do it. Oh. You're going to go the long way? Really? Why are you... Oh, come on. Oh. Okay, well, it got the direction and the name right, just didn't flip the screen around. Okay, we'll have a conversation later. Okay. All right, so how did this mess start? right? Like any software project, it started at literally the beginning with a screen, a stack of boards, and a motor, and me trying to make this happen. Right? You know those little successes, right? When you're writing a Python script and you finally got it to read the right field or whatever. It's the same. Okay. So then, hours of CAD to make this giant thing, which looked like this when it came out of the printer. So it got spray painted black, nice matte base coat. And then a lot of this. Yeah, a lot of that. In engineering, there's a thing we call integration hell. It happens in software too. It definitely is an engineering thing though. And the first engineering hell item that I had, engineering hell is, or integration hell is when, well, you try to put two things together that you wanted to go together and you thought they would go together and then they don't. That's it. So you can't really, well, it's pretty dark. You can only kind of see it. The black gear on the bottom is the first gear I printed, and it was centered perfectly on the post. And then I put that metal dowel in the middle, and guess what? It wasn't perfectly centered. So the gray one is perfectly centered on the metal dowel. So I fixed that problem, and then it was funny because it would like make a racket going around, and I was like, what is going on? And I finally somebody forgot that. Okay, but once I got that working, this happened. Okay, we're not going to get any, I'll narrate for you. I don't remember what I said. I think Disneyland or something, I don't know. Okay, so then I'm like, oh my goodness, what is happening? I thought this was going to work. Look at the code. Oh, there's a breakpoint in the code still. Okay, all right, undo the breakpoint, hold your breath some more, and nope, still there. Okay, so that was the very first time it actually did exactly what it did. Always celebrate your success, okay? Okay, so after that, it was time to mount the screen. I had grand plans for this screen. The first time I hooked this up, this happened. Why is it shaking? Like, it's moving, but like, it's holding a position and it's shaking. Okay. Well, for those of you that have ever messed with Raspberry Pi 5s, the hardware PWM doesn't have a software package for it yet. So it's all software PWM, which is a complicated way of saying that I need to send out a signal at a very constant rate, and it can't. So it does this jittery thing the whole time. Okay, well, there are also a bunch of other problems here. When I printed this, I mismeasured the sign, the screen. I thought it was going to fit past the gears. I was wrong, it didn't. I don't know if I misread the spec sheet or whatever, but I finally got there through a bunch of trial and error. This was the middle of that. These are not staged photos or staged videos. This is my real reaction. These are from videos of me. I'm going to make a YouTube video of this. This is a real shot of me going, what are you doing, you crazy sign? You're not doing what I want. Okay. But eventually, we got it working. Okay. Now, if you look at this very carefully, other than the fact that I haven't painted it yet, you'll notice there's a weird problem happening. The arrow is pointing down, kind of. It's sagging a little bit. Okay. So over Thanksgiving, I got a new printer, and that's just an example so you can see the sag. Okay. Over Thanksgiving, I got a new printer. I'm still experimenting with how to build things structurally. So I ended up having to add these metal bars on the bottom to give it some strength. That happened Friday last week. So it took a little bit of outside the box. I need to come up with a way. Okay. That is pretty much the story that I wanted to tell. This was a fun little project. It's been like 4 weeks, 5 weeks in the making. A lot of late nights getting it done. That picture of the spray paint, that was at like 11 p.m. It was very dark while I was trying to spray paint outside. It's hard to spray paint in the dark with black paint. I'm I'm gonna leave this up here while we play with it. Weird side note, these two images, I have a different AI project that I did where it records conversations in my office and it draws art based on those conversations. So I was practicing this presentation / talking out loud to myself, narrating for potential YouTube video cuts, and it made a Raspberry Pi. All right, sure, I'll take it, okay. And this is its version of my steampunk sign. Its version might be better. The whole gauge thing, that's pretty good. I wish I had thought of that. Sometimes I should ask it for some creative ideas. Okay, does anybody have any good locations that we can try here? Anybody got a good one?
Country whose flag has a bird and is purple.
Oh,
I believe there's only one.
okay, this is gonna be. All right, you want to say it? You have to say it loud.
Okay, yeah.
Ready? Okay, go.
A country whose flag has a bird and purple. Mexico does not have purple.
That is, yeah, it does have a bird.
It does have a bird. That part of
We'll give it one more. A country whose flag has a bird on it and is purple. What country is it? Okay, all right. I don't know if it's that direction or not. That might be subject to debate. But okay, any other ones? Literally anything. Yeah.
An island with big heads.
Ooh. An island with big heads. Well, I did it right. It is probably that direction, right? Roughly. It's like over there somewhere, right? It's between here and Australia. Yeah.
Somewhere cold.
Somewhere cold. Cold land. I don't know what Okay, it did get Antarctica that time. We'll give it at least partial credit. I don't know why I was so hesitant. Okay, it's on the yeah.
The nearest pharmacy?
I don't know. The nearest pharmacy. I will say that it does the geocoder. The geocoder does not know your location when it's doing this, so this might be funny. San Francisco. For some reason, if you put pharmacy in the geocoder, that's going to be the first thing you get back. All right, any other ones? No, that's it. All right, that's all I got. I'll let you go. If you want to come look at it or ask questions, please do. Thank you.
The Whisperframe has helpfully drawn an arrow in honor of the Anywharrow presentation that I've been editing here.